Yeah, thanks for coming. This is my biggest conference by far. Slide decks are terrible. I have learned this truth. I'm using Google Presenter, the slides things. I had to move videos into GIFs, which is a technology that happened before I was born. This is terrible. I must be doing something wrong. Somebody please help me. I am here to talk about fashion-driven development. That's what we discussed you shouldn't do yesterday. That's what I'm going to do today. You'll notice also that I added this subtitle that's not in your program. It's pretty aggressive, bad and ugly. Those are strong terms. I'll get to that. I'll tell you what I mean here. I really do actually like GraphQL. It's been a great language for us to work with, providing our data needs across various sorts of native apps and websites for us at Vogue in production. So we're using it. We love it. I am hearing a lot of buzz about it, though, and I just kind of want to provide some caution, provide some tools to help you in your journey. It's so hot right now, but maybe there's some reasons why you need some extra tools for your journey. But huge props to Lee Byron, Nick Schrock, Dan Schaefer, all the cool kids doing cool stuff, Relay, ISO Relay, Babel, a lot of cool people doing cool stuff in JavaScript. So thank you all for giving us the tools that we can build websites with. How many in the audience are using GraphQL in production right now? We got, oh, that's my team. Okay, so no one, great. So keep hands up for a moment. Who is playing with GraphQL right now? So using, playing, okay, who has used a query language before of some sort, MySQL, something, Mongo? Who has used an API before? Okay, cool. So nearly everybody should have some of the vocabulary we'll need to discuss this conversation. It'll be a bit technical, but it should be useful. So there's a specification. That is our Bible of GraphQL. If you haven't read it, please start. It's 19,618 words, so get started now. It reads like Wittgenstein. It's very like hierarchical. So if you enjoy philosophy, deep philosophy, then you'll love this. There's also kind of the apocrypha of the relay specific specifications. To really do a good implementation, you need to read all of them, which gets kind of interesting. I'll summarize some of these. Relay is React's query builder and caching tier within React is really, really useful. The reference implementation is in JavaScript. I recommend you use it. It's awesome. What else? Oh, graphical. Super cool. It is a query explorer for GraphQL. It's super useful, super interesting. I highly recommend if you're going to build an endpoint that you install that somewhere private potentially, but it really helps you explore through your queries and be able to build queries well and understand what your data actually looks like after you implement a schema. I also have a blog post that kind of details out our decision to use GraphQL and why we went that direction for mainly an iOS app. You know, it's 2008, or it's 2016 now. It was 2008 when the App Store came out. So we said, hey, it's been 8 years now. This seems really new and cutting edge. Let's make an iOS app. We decided to take some liberties along the way. I believe Ed told us yesterday that when you have a tight deadline to get on, that you should add as many cutting-edge technologies to it to ensure that you launch on time. So we took that advice. Now, for the recorded conversation later, Ed did not tell us that. He said to be conservative in your usage, but liberal in your learning, which I really appreciated. Cool, so this is kind of where we started. We looked at this and said, okay, what we have right now isn't great. We can't really scale this much further and add iOS app 2 to this. We had an old app that we didn't love. We have the summary API. And you see all those little crossed arrows. That's very confusing to hold everything together. It builds little kind of different representations of canonical data elements. That's not great. There's also WordPress over here, which is just very inconsistent and unclear in its data model. It goes through at least those 4 different locations to kind of decide on what it actually wants to tell you about an entity. This is a visual representation of the WordPress data model. Sorry. Okay, so this is where we ended up. So we attached the WordPress REST API to it, and then we reprocessed that in Graph, get something fairly sane into our new native app that we launched recently. And we also upgraded our existing web app to use some Relay as well. One of the interesting things that we certainly needed something sitting in front of this is that we needed to do markdown transformation, because as some of the conversations have happened this weekend, if you didn't know, HTML is just very brittle. It's highly tightly coupled to the actual display in DOM. And in even a React Native app, we don't actually have DOM to work with. So we need something a little bit more translatable. So this is our future. We can have GraphQL doing a nice divide between potential multiple data stores. We can just ask it for anything. We've upgraded at this point future app 1 so that it also is using Relay. So that's what I'm looking forward to. These are the versions of things that we ended up with in production. If you have complaints about anything that I'm saying, maybe I'm in an old version of something, I apologize. But these all are working together for us in production right now. We consider them kind of stable, almost. This is an example section of our schema. Okay, so this is an interface, super cool, content. It's implemented in an article. We add a few fields. There's also some contributors that get attached to content, and there's this little role object that kind of connects them. It's kind of responsible for building these relationships, naming the relationships. I'll hit that more later. Hopefully you've all committed that to memory because it is gone. Our usage looks something like this. So this is the most recent thing I pulled off of our feed the other day. It looks like an article that's probably relevant to everyone in the room. Hopefully you've all read it already. The Cult Pedicure Oil, that's our Memorial Day obsession. Seems great. So that's just what a query looks like, and that's how you, the response you would get on such a query. So what's good about it? I'm telling you good stuff. There's no over-under fetching. You ask for fields, you get fields. Great. What else? Well, with Relay, you can be very declarative in your component. You tell it what it wants. It's hierarchical. That's awesome. It's tightly coupled. It's tightly structured, hierarchical, typed, all that great stuff. Input and output. You know what you're going to get. Very deterministic. Query fragments you can reuse around, so you can build part of a query, use it in a bunch of different places. It's super awesome. It's self-documented and introspectable. I can't tell you how important this is. I have written API documentation, and it always sucks. It's very challenging to do. You have to specify what the potential request looks like with different query parameters, how it changes based on query parameters. You're doing a multi-dimensional thing to say, oh, cool, well, okay, then this is different, and oh, if you do that thing, then actually the whole structure is different, so this kind of breaks out this way. It really, really sucks. It's multi-dimensional, and that's challenging to represent in any sort of documentation. So being introspectable, when you define your schema, you add descriptions to things and say this is what this field means, and then let people inspect them as they go, and the type is also there as well. What else do we have? The read and write system, or the terms for query mutation are the terms for read and write. It splits out nicely. It's fully delineated down the entire query path. So you can be very clear on whether you're doing a write operation or a read operation. Very important. It is not a database, and that's just important as you think about this. Think about the data structure. In a properly normalized setup database, you're going to hopefully have a strong bias toward non-nullability. You want everything to be filled as much as possible, not a bunch of empty rows or columns along the way. In this, you want to be pretty nullable. By default, every field is nullable, and it's up to you to provide the constraints and actually say, no, this has to be here for this to make sense. So you're building your contract along the way. Just looks a little different than a database. Cursor-based lookups are super cool. Now, when we talk to a human, a common thing for us to say is, what's up? What's new? We're asking about a delta there. What's happened since I've last seen you? That's very common in human interaction. In API interaction, that's actually something we want to know very often. What is new in this app since I've last seen it? But in REST, in any of the standards I've really looked at, HAL, HADOS, those kind of things, there isn't a great spec that says, okay, yeah, this is how you do that. This is how you implement a delta-based or cursor-based lookup here. But there's a great standard here in Graph, which we'll get to, is a confined language, which I find super interesting and useful. It kind of limits the damage you can do, which is great. It's not Turing complete, don't worry about that. There's minimal runtime changes. Supplied variables, you can only actually add values to that you use in the query. You can't like store a subquery onto it and then do something conditional based on that subquery, run query 2 or query 3. It's all just very inline, straightforward. It sacrifices its completeness. It takes some things out, such as infinite loops, which, I mean, I'm totally for. That would be bad and kind of undecidable and undefined behavior if you had that. So you could have fragment A that references fragment B, and then fragment B that references fragment A, and then if you actually use either of them in a query, you would have an infinite spread, and that would be really bad. What would you do with that? But I just find it interesting that the language is capable of creating these undecidable propositions in kind of a number theory kind of situation, or even English. Like we can come up with the phrase, I can't speak a sentence of English, which is also a paradoxical situation. So there would be paradox here, but it's removed as much as possible. Kind of reminds me of this situation where you have a system that's maybe too powerful for... I'll shoot. All right, what's some of the bad stuff? As I mentioned, there's a lot of different specifications. There's 4 specifications to really understand what's going on here. That becomes challenging. And you're not able to know. There's not a support kind of an idea. There is for one of the features of the language, but it's very minimal. A lot of the important stuff in the language is not specified on whether it's supported or not. There's not a version to the language. You can introspect, but you can't ask about the version. So that would be super helpful. I think that a lot of this stuff needs to float up to the main spec. The relay stuff is really, really helpful, really useful. You don't have to use it everywhere, but it would be great if it were actually an agreed upon just part of GraphQL. Cursor-based lookup, so what are they? So when you make a request, you get this item back. You get this base64-esque kind of looking thing that you can give it later and say, hey, give me more items from this position. Cursor, cool. But interestingly, they're not actually on the objects, they're on the connection. So on the left side here, we'll see a connection. A connection is a item, an entity that is provided by Relay. It extends, it provides an interface really. So it has 4 properties on it, before, after, and first and last. And by using those 4 items, you can build your query how you want to. You can build your next page of your things. So then we ask for these things over here, we get a cursor back. Cool. So now we can add that cursor and say, hey, give me the first one after this position, and it will give us our next page. Unfortunately, though, so what if we're deep linked onto content? So normally in a flow, we probably are thinking about people coming to content on our website or our app from a list view. They come through a list, a homepage, they click on something, great. So we came through something that looked like that on the left, then we go ask for more information, and I'll show you how you do that in a moment. And so we got our cursor, we know where we live. So when we want to come back into a list, we're able to drop right back in, know what happened because we have our cursor that brings us back in. What happens if we go the other way with a deep link? The cursor we just described does not exist on this entity. So how do we get back into our list view? Now, I understand why this isn't part of the spec as default, because you could have a non-deterministic list. You could have something by some outside system that says, oh, based on your personalization stuff right now, this is where you are in the list. But for us, the cursor is a derivative of properties of the objects. So we actually know at any point where this item would be within the list. It's chronological, so it's a property of the publish date. So we can determine that from the entity itself, which we actually do. I actually have this __ cursor on our entities. So that's just a little hint, little tip that we did that's provided this use case of deep linking. Nick Cage approves. All right, error handling. It's not well defined right now. So the first step that is defined is that it's got to be valid. Cool, we can deal with that. So it actually checks the query. So then what happens on resolution if we hit an error of some sort? Well, if we hit it in a field, we attempt to, we have to log that error, and then we make that field null. So then we have to go up the path, and if that was a non-null field, then the parent has a problem. Now the parent is an error, so maybe we log another error, that's kind of unclear, but then it has to become null because it can't resolve itself at this point. So if we go all the way up the stack and we null everything out, then we end up with this null data object, and then we also log 1, potentially multiple errors along the way, and we know that we're in a bad state. What about anything short of that? So in this situation, this is a very simplified version of our content. We have this named arrow that we call photos tout that links a featured image to an article. What happens if this is busted? Well, it's actually cool because in our schema here, it's not indicated as non-nullable, so we should still be able to render this. We've also looked at the spec and said we're also supposed to log an error. So we're somewhere in this in-between, so we're supposed to provide information forward to the client and say, hey, I got some data for you. It's not null all the way up. you may be able to render this, but there's also an error, just so you know. I tried to resolve something. I wasn't able to. I'm sorry. But what do you want to do? You want to try and render this? Yeah, highlight. Cool. So the default implementation in Relay, though, says, hey, if there's any error, bail. We're going to reject this thing. You're done. So this caused us some issues along the way. We decided, and this is apocryphal or maybe even heretical, that we wanted, if there is data there still that's not null, even if there's an error, that we're going to try and render it anyhow. Again, it's the server's responsible for ensuring that what comes forward is works with the schema. And we've ensured that our template render is consistent with the schema. So long as we get a schema valid item back, we're going to try and render it. We should be able to render it. What about other types of error states? So in a REST world, we have like a canonical reference to this entity. This thing actually lives right there. We can very specifically return this 404 error and say, hey, no, there isn't a thing here. You thought that there was this ID, whatever. It just doesn't exist. We would give you a different error if we had some trouble trying to resolve it, but it really just doesn't exist. There's not a thing. In Graph, you do that, does that mean it doesn't exist? Or did we have some sort of issue looking it up? Did you come across the wrong route to get that? I don't know. That's another thing that you just kind of got to find a way on. So far it hasn't caused us major issues, but there's not anything clear in the specification on it. Sometimes you just got to put together the tools you have. Cool, how about gets and posts? So there's the relay default network layer. We've extended this a little bit. So again, I mentioned that queries are fully separated from mutations. So we have read-only operations coming down this pipe. We said, cool, we understand these operations to be cacheable. We'd like to make these gets, and so we have. The only issue here that I foresee, which we don't have massively long queries, but if that became an issue, then you'd have a size consideration here, and you might go post again at that point. But this has been very helpful for us in our architecture as well. Just an extension that we also made. Of course, there's the Big Lebowski where John Goodman is yelling, make it a get. Big Lebowski fans, anyone? Was not what he said. All right, so the node route and interface, also part of Relay. So here's our situation. We came across an item from some sort of list view. Now we want more information about it. We have its ID, it's typed, we know what this is. This is this entity, but I only have 3 fields on it. I need some more. How do we do this? Well, there is not a connection between an object type and a route, nothing hard to find there. There also is no contract even to have a lookup route per object type. So if we have this situation where we want more items, where do we get it? We have the ID, we know we should be able to refetch this in somehow. Well, here's the solution. You have to have a globally unique and identifiable ID. There's a node interface idea that is implemented in a node route. Between those few things, you are able, so the global identifiable ID is really critical. So without doing a lot of work, throwing a random ID to my database, my data store, and say like, hey, do you know anything in any of your types that look like this? It's what we end up doing is we take the type that we understand, a delimiter and the ID, and base64 that together, send that to the client, and that becomes the new ID. So we can very easily take that apart and say, cool, you look like this type, I'm going to send you down that resolver, and you're good to go. So now we have something that looks like this. Now our question marks becomes node, we send our ID to it. It obviously would not be 1, 2, 3, 4. I understand that it's not base64, but you get the point. So you send an ID, and we're good to go. How about this? Contextual overrides and relationships. So this is something we deal with a lot in publishing as a whole. In REST, I probably would have cheated and done something, this is like the graph version of it, that looks something like this. I would have probably taken the roles and just stuck them maybe next to the name and said like, okay, cool, you're the author here, hey, you're the editor, good to go. They're just child properties of the content item. Well, in Graph, these are typed items. These are actual entities. So if we store that there, we've now poisoned that thing. Now that record is always going to be role whichever. Or if we somehow merge over it, then now it's role 2. Now it's an editor, and then we go back to article 1, and now what was an author becomes an editor. How do we know what to do with that? We've done, that's just part of the spec, we've done something that looks like this. So we build these little intermediary relationship managers. I kind of hate them, they're kind of gnarly. I think that we can probably work with them a little bit more. Just a little bit of data munging here will make things better for sure. So much better. Okay, so we've done this pattern a number of times. It just kind of exists. I kind of hate it. I don't necessarily, well, now I know why I hate it, but it's a third man issue. Like, these items both exist and they don't exist. The relationship is a thing, but it's not a thing. It's a named arrow. It's trying to name the connection between things, but it doesn't ever resolve itself anyhow. So what are our rules? Well, we can't select beyond a scalar value. Okay, cool. We can't subselect a string. That makes sense. We also need to ensure our query goes all the way down to the leaves. It actually looks into scalar values. So that the shape matches on either side. The query, the response, both have well-described shapes. Let's consider another situation. Arbitrarily named relationships. What if we let the editors actually choose what this relationship is? Right now it's an enumerable set of items. What if it becomes that they can have a free-form text box that they can connect these to? That is a crazy idea. I would not want to do this. But let's say that we do. Let's say that's a new requirement. So now this person is now spiritual advisor for this article. Cool. How do we represent that? We can't right now. It would be pretty complex to try and redo that. What about long rule sets or highly nullable fields? You could end up making a massive query for very little additional information, and we have something that looks kind of like this. So let's just consider, Della talked yesterday about potentially bringing your styling into your data store of some sort, being able to move that around. Try doing that in Graph. This is just a super subset of the CSS rules. You want to query across all of those all the time? I certainly do not. But we do want a structured response. We don't want to like sub-JSONify this, like unparse it and like move it along as a string. That would be pretty nasty, I think. We could end up with a lot more query than we have interesting result. This is a data structure that we built to kind of try and do this. This gets a little bit better, but it's also kind of nasty. This is a list of lists. So they're scalable entities, results. We can't actually confine it to be a length of 2, but it's a key value, scalar results. Kind of does what we want. We just rolled this out. It gets us closer. We can process all the rules to the right, but in some of these cases they're somewhat dynamic. We know how to render it, but we don't know what might be there. There actually might be a high level of permutations of options, so we can't really well describe what we could get. So this allows us to achieve that. I kind of really just like it. Let's go for a little more heresy. Cool, here's a proposal. What if we had star fields? So back to this last item, then suddenly we get a structured response. That looks pretty cool. We still have a well-described shape on the left side. We just don't necessarily tell you about every field. So I think that's kind of interesting. You could also move it up a level. So remember our contributors. We could potentially have our spiritual advisor hanging out on the right side, and we wouldn't have to indicate it as well. So we could have star fields in multiple positions. You still have to describe the shape all the way down to scalar values, but suggesting that the star could be a scalar value. This does not exist in the spec. Just to be clear, it is not there at all. I will be proposing at some point is complete heresy, so please do not go to any of the core members and say, hey, that star field, where is that? Takeaways, jump in. Consider using gets. If you have queries only, if you have the read kind of side of the pipe and you want to use some sort of caching on it rather than trying to figure out how to cache a post, which is not fun or a good idea, I recommend you use some gets. Just be smart about it. Watch out for poisoning the children with relationships. That's good life advice, and that's also just particularly a situation in Graph that you may not have dealt with. Maybe you're doing something bad in REST right now, but it's not really affecting anybody. It will affect you in Graph, I promise. Add cursors when they're deterministic. You know, why not? It's been a really helpful tool for us to use. Figure out your error handling. Again, it's pretty loose right now. You have to kind of decide like, okay, cool, this error actually doesn't mean something to me. I can still render. Oh, this error does mean something to me. I need to halt in client everywhere. Simplify your data structures. If a list of lists works for you, maybe that's what you go with. You know, I'd love for them to add a few more pieces to the spec to just make a few things more explicit, and I don't think they'd add much damage to the spec. Still keep things very clear, but Sometimes you have to do some strange stuff to make things work, just so it's well documented and your team understands what you're trying to do. I recommend doing it. When using Relay, your rule is that the schema is your contract. Whatever you're doing on the forward of that needs to abide by the contract. You have to be able to render whatever the data is. So use your schema as your contract with nullability. I think that's it. Thank you.
The separation between like web and iOS, right? You're trying to provide for two different types of clients?
I would say it's actually trying to combine them.
Right.
So that we can service multiple providers and not have to indicate every field on multiple API endpoints. We just describe the fields once and then let the client decide what they need.
Definitely, right. So it's like providing an interface for any sort of like consuming client. So do you see this as now it's going to be trivial to add sort of new types of clients, watches, internet, IoT devices? Do you have any plans for that? Are you guys talking about that stuff yet?
We're trying to figure out some of the next technical pieces that we'll be adding, but yes, it makes any new clients very easy to work with.
Yeah, very cool. Also, are you excited about the pedicure oil for Memorial Day? Unfortunately, Tom Dale's not here. I was like, yeah, he'd be very interested in some pedicure oil. That's a fantastic blazer you're wearing.
Thank you.
I really dig it. Crushed velvet is a bold choice. I'm very excited to see.
Fashion-driven development.
Fashion-driven development. I tell you what. When I was we have a few of my ex-Guilt peers here. Do you often also get comments about that you don't look like a developer? You know, I generally get I don't know, complimented, critiqued for why aren't you wearing jeans and a T-shirt? Is this something you share?
Yes, I feel like I have inferiority complexes in conferences because I'm not wearing the right uniform.
Right on. Right on. So, any tips for like sort of migration, right? So I think like as we're talking about GraphQL and at this conference last year, there was sort of a lot of talk about like React and GraphQL and Falcor specifically. And sort of as people like sort of migrate, do you have any tips for sort of what to think about? Did you sort of start at the core of your platform, or did you like find something that was like sort of like a little less risky and sort of like start there? Like any tips for like migration in general?
Yeah, I mean, part of the challenge is especially around linked entities. So like article links out to a lot of other content types, the authors, the creators, the tags, taxonomies. Finding a small piece that you can start with and do something interesting with, I think, is pretty critical. You learn so much by working with it. My team has gone from 0 to 60 plus in a short amount of time by just doing it. So hopefully my talk was trying to be fairly representative of all the oh crap moments of like, okay, we're doing this live per se, we're building this out. Right. This was kind of unforeseen in the spec, and there just isn't really much information about this. So here's kind of what we decided to do. Right.
Catch as catch can. All right. Thank you so much, ladies and gentlemen. Kenton Jacobsen.